Today we're going to spend a little more time adding and subtracting rational expressions, but we're also going to look at rationalizing the numerator. So we've talked about rationalizing our denominator, where we make our denominator a nice clean looking number. We don't always have to rationalize the denominator. We could rationalize the numerator. And we look at rationalizing the numerator especially as we get into our preparation for calculus and pre-calculus. So we'll talk about that as well. So here I have two examples. We'll look at the first one here. We have a radical of 3/8 plus the square root of 6/2 minus the square root of 2/27. And I'm going to go ahead and add and subtract these radicals from each other and to each other. So the first thing we can do, since we have the square root or the radical of a fraction of the entire fraction, we can break that apart and say the square root of 3 divided by the square root of 8. And to that we can add, here's an interesting fraction. We have 6 divided by 2. We can actually just go ahead and make that the square root of 3. Because 6 divided by 2 is 3, we can go ahead and divide those values into each other. Minus, here I can go ahead and take the square root of 2 divided by the square root of 27. Now I can go ahead and simplify any of my radicals that I know something about. So here I have the square root of 8. I know that 8 is 4 times 2, so 4 is my perfect square. So I have the square root of 3 over, or divided by 2 radical 2. To that we're going to add radical 3, and from that we're going to subtract radical 2, and then 27 is 9 times 3, so we get 3 radical 3. Next thing I want to do is go ahead and rationalize my denominator. So to rationalize my denominator here, I'm going to multiply by radical 2 over radical 2. That gives me radical 6 divided by 2 times radical 2 times radical 2. My radical 2's will give me radical 4, which is 2 times 2, or 4. To that we're going to add the square root of 3. Minus, again here, I'm going to multiply by the square root of 3 over the square root of 3 to rationalize that denominator. And I get the square root of 6 divided by 9. Again, the square root of 3 times the square root of 3. That gives me the square root of 9, which is 3 times the 3 gives me my 9. From here, I can go ahead and find a common denominator. My common denominator in this case is going to be 36. So I'm going to multiply 4 by 9 to get 36. So I'm going to multiply my numerator by 9 and get 9 radical 6. To that, we're going to add. Our denominator in this case is 1. So if I have 1 as my denominator, I'm going to multiply it by 36 to get my common denominator. So I'm going to multiply my numerator by 36 and get 36 radical 3. And multiply my radical 6 here by 4, because 9 times 4 gives me 36. I multiply the 4 to the top as well. And now, final step, we can go ahead and combine like terms. So we take 9 radical 6 and subtract 4 radical 6 from it, recalling that we're going to only perform the operation on the 9 and the 4, not with the radical 6, because the radicals act like variables. So we have 5 radical 6 plus 36 radical 3 divided by 36. And there's our answer. In example 2, we're going to do the same, very similar process. Here, though, we have a radical that doesn't have a denominator, so we're going to make that a 1 at this point in time. And we can go ahead then and break these up. We have the square root of 5. 18 is 9 times 2, so I'm going to break that into 3 radical 2. To that, we're going to add radical 2 over radical 5. And finally, our radical 10 over 1. We're going to go ahead and rationalize each of our denominators. So we have radical 2 over radical 2, and we get radical 10 divided by, again we have 3 times radical 2 times radical 2. Radical 2 times radical 2 is 2, times 3 gives us 6. Here we're going to multiply by radical 5 over radical 5 to get radical 10 over 5. And then plus the square root of 10 over 1. We now can go ahead and find a common denominator between 6, 5, and 1. That's going to be 30. we multiply 6 by 5 to get 30, so we're going to multiply the radical 10 by 5, and you get 5 radical 10. To that we're going to add, we multiply 5 by 6 to get 30, so we're going to multiply the numerator by 6 as well, so we get 6 radical 10. And then the radical 10 we're going to multiply by 30, because we multiply 1 by 30 to get the common denominator as well. So here we have 5 plus 6 plus 30 gives us 11, and again that radical is going to stay the same. We do not change the radical when we add. Those radicals are going to act just like variables, and we never change the variable when we add, same way in this case. And our denominator is going to be 30, and there you go. Finally, I want to go ahead and talk about rationalizing our numerator. Again, we've rationalized our denominator. We can also rationalize our numerator. So the first thing I want to do is go ahead and break this radical 3/8 into radical 3 over radical 8. We can simplify the square root of 8. Remember, 8 is 4 times 2, so that gives us 2 radical 2. Now to rationalize the numerator, we do the same process that we did when we rationalized our denominator, but we do it with the numerator. So what do we multiply radical 3 by to get a perfect square? Well, we multiply by radical 3, don't we? So we have radical 3 times radical 3, which is 3, divided by, here we're going to multiply radical 2 to radical 3, and we get 2 radical 6. And that's going to be our answer as we've rationalized now the numerator, not just the denominator. And then finally, example 4 here, we've already broken up the radicals. So we have radical 12 over radical 5. 12 is 4 times 3, so we have 2 radical 3 over radical 5. So we like to always clean up the radical if we can. It makes our life a little easier as we simplify later on. Now to rationalize the numerator, we're going to multiply by, again, that radical 3 over radical 3. So here I have 2 times radical 3, or 2 times 3, which is 6, divided by the square root of 15. And now I have a rationalized numerator. So that gives you an idea of adding and subtracting rational expressions and rationalizing our numerator. If you have questions, please let me know. Good luck and enjoy.